Hello everyone, welcome back to my channel SF with AK. This is part 2 of our Apex design pattern series. In part 1, we covered the creational patterns, singleton, factory and builder, three types of the creational patterns. Those were all about how the objects are created. Today we are going to talk about behavioral patterns. And again, we have three types of behavioral patterns: strategy, observer and command. These patterns answer a completely different question. Not how the objects are made, but how they talk to each other, how they communicate, how they collaborate. And once you understand this, the way you write triggers, services, and business logic in Apex will never be the same. Let's jump right in. So, here's what we are covering today. First, a quick recap of part 1 just to get everyone on the same page. If you have not watched the video, I would suggest you go and watch the part 1 of the series, and that will help you better understand this part. Then we'll go through three behavioral patterns one by one: strategy, which lets you swap algorithm at runtime; observer, which is about broadcasting events cleanly; and command, which lets you encapsulate actions for things like undo and logging. For each pattern, I'll walk you through the concept first, then we'll look at the Apex code, and at the end, I will tie it all together and give you a preview of part 3. Alright, quick recap from part 1. We covered three creational patterns. Singleton, one instance of a class, you get a private constructor, a private static variable, and a public getInstance method. That is it. Three ingredients, and you will have a singleton class. Factory, your centralized object creation. The caller depends on the interface, not on the concrete class. So when you add a new type, you just add a new class and one line in the factory. Nothing else changes. And then builder. For when you have the objects with a lot of fields, you build them step by step using a fluent chain. And the build method acts as a single validation gate that allows you to throw the error as per fields one by one, or you can just send a generic error. Those were all about creating objects the smart way. Today, we are moving into behavioral territory: strategy, observer, and command. So, what are behavioral patterns? In simple terms, if creational patterns are about how the object came into existence, behavioral patterns are about how the objects communicate and collaborate once they exist. How do they share the information? How do they delegate responsibilities? How do they react to events? That is what these patterns show. Strategy is about sweeping algorithm at runtime. Observer is about broadcasting to the independent subscribers. And command is encapsulating actions as objects. Let's start with the strategy pattern. Okay, the strategy pattern. This is one of my favorite because it directly solves a problem I see in almost every Salesforce org. So what is the problem? Imagine you have a class that calculates discount, and the discount logic changes depending on the customer tier. So you end up writing if else blocks. If enterprise, do this. If SMB, do this. If it partner, do something else. If it's a small organization, do this. And every time a new tier comes in, you are back in that same class, adding more conditions and hoping you don't break the existing ones. That chain of if else becomes maintenance nightmare. And it violates something called the open closed principle, which says code should be open for extension but closed for modification. So how does the strategy fix this? Think of a GPS navigation app. You type in your destination, the app gives you options: fastest route, fewest tolls, avoid highways. Each one is a different strategy, but the app itself, the core navigation logic, doesn't change. It just accepts whichever strategy you pick and runs with it. That is strategy pattern. You define an interface, and each algorithm becomes its own class implementing that interface. The beauty is the context class, the one doing the calculation, never changes. You extend the system by adding new strategy class. That is it. When you should use this: discount engines, pricing calculators, validation logic that varies by the code type, data export in multiple formats. Anytime you have an algorithm that needs to be vary independently from the code that uses it. Let me walk you through the code. At the top, we have the one discount strategy. There's the interface which only has one method, apply discount. That's the contract. Every strategy has to implement this contract or this interface. Then we have two concrete strategies, volume discount and flat rate discount. Volume discount, check the amount and applies tier discount like 25% off orders over 10,000 or 15% off for orders over 5,000. Then the flat rate discount, take a percentage and applies it straight across. Now, here's the important part. Look at the bottom. Caller creates the right strategy first based on the customer tier. If it's enterprise, use volume discount. Otherwise, we use flat rate discount with 10%. Then it passes that strategy into a code calculator and gets the final amount. We are passing the strategy here. If tomorrow you need a seasonal discount, you write one new class and you add one line where the strategy gets selected. The code calculator, the interface, the other strategies, nothing changes. Strategy replaces conditional logic with composable classes. The context never changes. You extend by adding new strategies. Let's see this live in the Apex class. I have my one discount strategy interface, which has one method. Then I have volume discount, I have flat rate discount. These are separate classes that implements that one discount strategy. And then we have code calculator. In code calculator, we have the strategy that will be passed. Then we have calculate final amount. We'll pass the amount and it will return after the discount. Now it does not know which strategy it's getting. We are passing that dynamically and it's calculating the discount and returning the amount dynamically. Now let's say we are anonymous window and we are passing the tier as enterprise. Now first I'm just checking which tier is this, and based on the tier I will use which strategy I need to use. If I need to use volume, I will use volume. If I need to use flat rate, I will use flat strategy. Then I will pass that same strategy into the code calculator class and then I'll call the calculate final amount method with an amount. Now let's see what happens. So the code ran and we can see the final amount is 11250. Now let's change this to something else, maybe SMB. And without changing the amount, let's execute. And you can see the difference. We have a different price for this. So that is how the strategy pattern works. Let's go back to the slides. Okay. Now I know some of you might be thinking this looks just like the factory pattern. Both uses similar interface. Both uses different classes to route, but the strategy and factory are different. The difference is in the intent and not the syntax. The factory answers the question which object it needs to create. It's about creation and not the strategy. The caller says, give me the right handler of this type, and then factory returns a new object. In strategy, it answers the question, how should I perform this operation? It's about behavior. The caller says, use this algorithm to calculate the result. The strategy isn't creating something, it's computing something. So one-liner to remember the difference. Factory decides what to build. Strategy decides how to behave. Both uses interface, but for entirely different reasons, for different purposes. Once you see the intent clearly, you will never get confused again. The difference is only in the intent and not the structure. Okay, let's move on to the next one. Observer pattern. What problem does the observer pattern solve? You have a trigger on opportunity. When a deal moves to closed one, you need to send an email, create a follow-up task, post a notification to Slack, maybe update a dashboard or something. You can do 10 things. Now, the basic approach is to pull all of that into a trigger handler, and it works until you need to add a fifth action or a sixth one. And suddenly your trigger handler is 400 lines long, impossible to test. And every change risks breaking something else. This is the problem that Observer solves. Think of a new agency. When a breaking story happens, the agency publishes it. Every newspaper that it's subscribed gets it automatically. The agency doesn't know or care who subscribed to that. It just broadcasts the story and all the subscriber will get that. That is exactly how the observer pattern works. You have a publisher that is your trigger or event source, and you have observers, independent classes that each do one thing. The Slack notifier posts to Slack, the follow-up task creator creates tasks, the email sender send email. Each observer its own class. Add a new reaction to the event, you write one new class and subscribe to it. You never touch the trigger, you never touch the observer. This keeps your trigger clean, your logic decoupled, and your code testable. You will be able to test each part separately. Now let's see the code. First, we need to define the interface. One method on update, which will pass the new opportunity and the old opportunity. Then we create our observers, Slack notifier, follow-up task creator, or we can have multiple. Now the publisher, the opportunity event publisher, it maintains a list of subscribers. You call the publisher.subscriber and pass it into your observer. Then in trigger, you loop through the records and call the publish.notify all. Well, that's how your trigger becomes clean. Let's see the code directly in the org, and I will be able to explain it better because it is a long code. Let's go to the classes. Okay, we have a case trigger. The trigger is just one line. It calls the trigger handler and pass the old case and the new case. You can have different conditions here. That's a different story. In trigger handler, we are doing the main work or the heavy lifting. We are initializing the publisher. Then we are subscribing new classes that we want to subscribe. You can have different conditions, doesn't matter. Then we are iterating all the new cases, and we are checking the condition if we need to pass that or publish that or not. Then if there are cases to publish, we will just use the publisher and publish all the cases at once. Now what happens in the background? We have an observer class interface, which is just has one method on case closed. It accepts a parameter list of cases. Then we have different observer classes, survey email observer, follow-up task creator, chatter post observer, and all of these observers work independently. We will call these not one by one, but just by one method. We'll just use observer case close publisher. This is the publisher class that handles the publishing part, and it does not care which objects you have subscribed or which classes you have subscribed to. It will just publish those. So we will just call this method publish, send a list of closed cases. We have already added the observers here when we subscribe those in trigger handler. So when we subscribe the different classes, we inform the publisher which one to subscribe. We pass each different observer, and then when we call the publish method at the end with just single list of cases, it goes in this, and for each observer it will pass the same list of cases. Now we are just doing it once and it happens in the background. So that is how the observer class works. Okay, let's go back to the PPT. Last one for today, the command pattern. The problem here is totally different. You have actions that needs to be undo, that needs to be logged or replayed. Think about a wizard where a user goes through multiple steps and needs the ability to go back, or an admin tool where you want to have a full audit trail of every change that you made. Now, when you call the method directly, like update the record, the change, the field, there's no way to track what happened or reverse it. The action is gone the moment it executes. The command pattern fixes this by running actions into objects. Think of a restaurant. When you order the food, the waiter doesn't sound your order at the kitchen. They write it down on a ticket, and then that ticket is the command object. It can be queued, it can be reissued, it can be modified or cancelled, all before it reaches the kitchen. In the command pattern, every action becomes a class. It has an execute method to perform the action and an undo method to reverse it. And we are adding a get description method so you can log it. Now use this when you need to undo something or roll back, or need to have audit trails, need to queue operations or multi-step wizards. Let's see the code now. Okay, this is how the code will look like. The command interface has three defined methods: execute, undo, and get description. Every command has to implement all three. That is the restriction put by the interface. Then we have a concrete class, update opportunity stage command, that implements the interface. Now we have variables, opportunity ID, stage, new stage, and old stage. Then we have a method, update opportunity stage command, which accepts the ID and the new stage. When we initialize the class, we assign the new stage to the stage that was passed to the class. We will capture the current stage. Now we have execute and then we'll undo and get description. Execution will look something like this. Command executor is equal to new of command executor, then we'll executor.run and we'll pass the class name, ID and the new stage name. Now if we want to undo it, we'll just use executor.undo last and it reverses the stage. Let me go back to the class and you will be able to understand it better. Okay, we have the interface with three methods. We have a class, update opportunity stage command. It implements the command and have the variables opportunity ID, new stage, previous stage. Then this is the constructor where we pass the opportunity ID and the new stage. We capture the opportunity ID, the new stage, and we query the previous stage so that we can undo it later. Now we have execute method where we are just updating that opportunity using the ID and the new stage. Then we can undo the stage if needed. We will just update it back with new opportunity ID, and we already captured the previous stage when we initialize the constructor. And at the end, if we want to get a description after successful updation, and let's say we are not undoing anything, we just want to get the description, we will just call the method and it will return the stage change. What was the previous stage? What is the new stage? What was the opportunity ID? And all that. That is how the command pattern works. It gives you control over the class. Let's go back to the PPT. Okay, this is wrap up for the part 2. Today we covered 3 different behavioral patterns. Strategy, swap the algorithm at runtime using composable classes. The context class never changes. You extend it by adding new strategies and it follows the open close principle. Then observer, decouple the event source from creation. Your trigger stays clean. Adding a new action means adding a new observer class and subscribing to that class. Nothing else changes. Then we have command pattern. Turn action into first class objects. You gain the ability to log, undo, queue, and replay. All things are impossible when you call the method directly. Well, thank you for exploring the part 2 of the Apex design pattern. Now we know about the creational patterns, we know about the behavioral patterns, and in the next session, we will talk about structural patterns. If you found the session helpful, smash the like button, subscribe to the channel, and I will see you in part 3 of the video. Thanks for watching.